Hello students, today we are going to study very important terms in chemistry. They are oxidation and reduction. These are very important terms, very important basic ideas in chemistry, and it has far-reaching applications. In this lecture, we are going to study at least 5 definitions of oxidation and reduction. These definitions did not come into chemistry in one go. It was a long journey. Hundreds of years it took for these 5 definitions to compile. So, when you understand the meaning of oxidation and reduction in detail, you will be doing the voyage of hundreds of years. When early scientists knew that in the process of burning, that is combustion, the substance is combining with oxygen. Once again, when early scientists knew the fact that while the substance is undergoing burning, that is combustion, it is combining with oxygen. So scientists used the term oxidation for burning process, combustion process. When anything burns, the ordinary person, the layman, will say the substance is burning or substance is undergoing combustion. However, scientists with the raised collars will used to say the substance is undergoing oxidation. So the first definition of oxidation was introduced in chemistry. The definition is this: the process of combining with oxygen is called oxidation. Thus, the first definition of oxidation was this: process of combining with oxygen is called oxidation. Simultaneously, the definition of reduction was formed. What was it? If you use the opposite word for this, then you get the definition of reduction. So what do you mean by reduction? What is the opposite of combining? Removal. So the definition of reduction was this: the process of removal of oxygen from its compound is called reduction. So the definition of reduction is process of removal of oxygen from its compound is called reduction. See here, this is the compound of oxygen. When zinc oxide is heated with carbon, it will turn into zinc and carbon monoxide. In this process, we have removed oxygen from its compound. Why was the term reduction used? The answer is very simple. See the size of zinc oxide. It is having a big size, but after oxygen vanished from it, it became slim. In a routine language, we can say the big fat zinc oxide was reduced to zinc. That's why the term reduction was used, as if a fat guy is becoming slim. That is the reason they use the term reduction. Thus, burning was considered as oxidation, and removal of oxygen from its compound was considered as reduction. Some year later, scientists found out that combustion takes place even in the absence of oxygen. As for example, when a piece of sodium metal is introduced into the jar containing chlorine gas, then it burns. Similarly, when piece of sodium is put into fluorine gas jar, then it will catch fire and form sodium fluoride. Thus, it was realized that burning occurs even in the absence of oxygen. Scientists then realized that it was the time to widen the idea of oxidation. Everyone knew at that time that oxygen is a non-metal and chlorine, fluorine, etc. are also non-metal. So, in order to modify the definition of oxidation, they only have to substitute non-metal, a wider term, at the place of oxygen. And the second definition of oxidation was introduced in chemistry. Thus, definition of oxidation was modified. What is it now? Process of combining with a non-metal is called oxidation. Obviously, if you change non-metal by the term metal, you will get the definition of reduction. Process of combining with a metal is called reduction. Let us recollect this example once again. Who is combining with non-metal? The answer is sodium. So, sodium is undergoing oxidation in this particular reaction. Ask the another question. Who is combining with metal in this reaction? The answer is chlorine. So we can say chlorine is undergoing reduction. Similarly, fluorine is a non-metal and it is combining with sodium, which is metal. So we can say fluorine is undergoing reduction. Sodium is combining with non-metal. So we can say sodium is undergoing oxidation. In those days, hydrogen was considered as chemical opposite of oxygen. So, if we substitute hydrogen by oxygen and removal by combining, once again, if we take away oxygen and if we write hydrogen, and simultaneously if we remove combining and if we put removal, then we get third definition of oxidation. So the third definition came into existence. What was it? Substitute combining by removal and oxygen by hydrogen. So the definition was this: process of removal of hydrogen is called oxidation. Obviously, we can say process of combining with hydrogen is called reduction. Process of removal of hydrogen is if oxidation, then obviously process of combining with hydrogen is called reduction. So please remember the definition of oxidation in quick succession: process of combining with oxygen, process of combining with non-metal, process of removal of hydrogen. Similarly, process of removal of oxygen, process of combining with metal, process of combining with hydrogen is called reduction. There was a lull of some 50 years, and finally science entered into new era. Scientists drilled inside the atom and found out fundamental particles such as protons, neutrons and electrons. It was realized that in order to complete octet in the outermost shell, sodium atom is losing electron and chlorine atom takes electron. Now recollect the definition of oxidation. Second definition: process of combining with non-metal. Who is combining with non-metal in this reaction? Sodium. It means that sodium is undergoing oxidation. And much later it was found out that in this reaction sodium is losing electron. So please remember, sodium is undergoing oxidation, sodium is losing electron, A equal to B, A equal to C. So obviously B equal to C. And there came fourth definition after a long break of some 50 years. And what is the definition? The fourth definition: loss of one or more electrons is called oxidation. Once again, LOSS, loss of one or more electrons is called oxidation. Similarly, in the same reaction, chlorine is gaining electron and at the same time chlorine is undergoing reduction. So we can define reduction as this: instead of loss of one or more electrons, we will be writing gain. So what must be the fourth definition of reduction? Gain of one or more electrons is called reduction. Once again, look at this particular reaction. What is actually happening in this reaction? Sodium is combining with chlorine to form sodium chloride. Sodium alone has no charge. Similarly, chlorine alone has no charge, but after transfer of electrons, sodium will acquire positive charge and chlorine will acquire negative charge. So please remember, sodium had no charge before the reaction, and now after the reaction it has positive charge. Similarly, chlorine had no charge before the reaction, but after the reaction it acquires negative charge. Instead of charge, we'll be using a wider term, and that is oxidation number. So once again, before the reaction, what was oxidation number of sodium? It was 0. And what is its oxidation number after the reaction? +1. Thus, what actually happens here? During this particular reaction, sodium shows increase in its oxidation number. It was 0 before the reaction and now it is +1. 0 to +1. So what is happening to oxidation number? It is increasing. So final definition, the fifth definition of oxidation was introduced. What is oxidation then? Increase in oxidation number is called oxidation. Similarly, oxidation number of chlorine before the reaction was 0, and after the reaction it becomes -1. 0 to -1. So what is happening to oxidation number? Please remember, instead of charge we use the wider term, and what is it? Oxidation number. What do you mean by oxidation number? You will study later. Oxidation number is nothing but the numerical charge that we assign to the atom in a molecule. Once again, the numerical charge that we assign, that we give to an atom in a molecule is called oxidation number. We will also study that oxidation number of element when it is in the uncombined state is 0. So oxidation number of sodium before the reaction is 0, and after the reaction it becomes +1. 0 to +1, increase. That's why increase in oxidation number is oxidation. Oxidation number of chlorine when it is in the uncombined state is 0. As per the rule, we will study it later. And oxidation number of chlorine after the reaction is -1. Thus, oxidation number of chlorine decreases during this reaction. So, decrease in oxidation number is called reduction. So, these are the 5 definitions of oxidation and reduction. Please remember, in organic chemistry, this definition is commonly used for oxidation, and this definition is commonly used for reduction. So whenever you come across the terms oxidation in organic chemistry, paper 2, you will be using this particular definition. In organic chemistry, oxidation has only one meaning: process of combining with oxygen. And even reduction has only one meaning. In fact, the most common meaning, the commonest meaning of reduction in organic chemistry is this: process of combining with hydrogen is called reduction. As for example, very often you will study that alcohol on oxidation yields aldehydes or ketones. It means that alcohol on combining with oxygen will turn into aldehyde or ketone. Aldehyde or ketone on further oxidation yields carboxylic acids. It means that when aldehyde or ketone combine with oxygen, they will form carboxylic acid. Thus, in organic chemistry, most of the time, oxidation is the process of combining with oxygen, and reduction is the process of combining with hydrogen. Carboxylic acid on reduction yields aldehyde or ketone. It means that when we make carboxylic acid to react with hydrogen, it will turn into aldehyde or ketone. Aldehyde or ketone on further reduction gives alcohol. It means that when we make aldehyde or ketone to react with hydrogen, then they will yield alcohol. So the commonest definition of oxidation is this, and reduction is this in organic chemistry.